Hi guys, Audrey here. Today, let's learn some trig integrals. All right, so to figure out the trig integrals, we're going to start by thinking about derivatives because we remember that an integral is answering the question, what is this function the derivative of? In other words, the integral of f prime dx, well, what is f prime the derivative of? Of f, plus or minus some constant. So we're going to kind of use this to try to come up with a list of trig integrals that in theory, technically, we already know. So let's try to make a list of our trig functions. Of course, we know sine, and we know cosine, and we know tangent. We also know cosecant of x, secant of x, and cotangent of x. So my recommendation right now would be pause the video for a second, make sure that you remember these derivatives. They're going to be super useful this semester when we're doing substitution. Also right now to figure out what the trig integrals are. So take a second, pause the video. All right, now let's fill them in. The derivative of sine is cosine x. The derivative of cosine is negative sine x. The derivative of tangent is secant squared x. Cosecant is negative cosecant x, cotangent x. Secant is positive secant x, tangent x. And cotangent x is negative cosecant squared x. So you'll remember all of the cos go with a negative derivative. All of the non-cos, sine, tangent, secant, go with the positive derivative. So the cos and the negatives go together. So try to remember that, because everything's going to be flipped around a little bit when we do the integrals. So if I think about these derivatives and I remember that the integral is answering the question, what is this function the derivative of? We actually have right here 1, 2, 3, 4, 5, 6 new known forms. So the first new known form would be that I know the integral of cosine x. What is cosine x the derivative of? Well, we just saw that it's the derivative of sine x. So the integral of cosine is sine x plus c. Now with sine, we have to be a little bit careful because the derivative of cosine x is negative sine x. So what is sine x itself the derivative of? That would be negative cosine x plus c. So here notice it's the sine that goes with the negative and not the cosine that goes with the negative. We have a few more integrals that we know over here. So I'm actually going to write all of our integrals. The next that we had was tangent x. If I look over there, I don't have tangent x on the right side. So I don't have tangent x as the derivative of anything. So I can't use those derivatives to find the integral of tangent x. So we're just going to skip it for this moment. Can I use it to find the integral of cosecant x? Again, no, can't use the derivatives. It's not over there. Can't do it to find the integral of secant x. And then my last one is cotangent x. So actually these four right here, I can't come up with a known form by taking those derivatives over there. That said, I do have four extra known forms for integrals that I should just be able to look at and know that came from those derivatives over there. So for example, if I were to ask you what is the integral or the antiderivative of secant squared x, well, secant squared x is the derivative of tangent x. So this will be tangent x plus a constant. The integral of secant x tangent x, well, that's the derivative of secant x. So we have secant x plus a constant. And then we have two more. We have the integral of cosecant squared x dx. And we see that that's the derivative. Well, negative cosecant squared is the derivative of cotangent. So this will be negative cotangent x plus c. And then we can also do secant squared x dx, which is the derivative of, I already did secant squared x, cosecant x cotangent x, my bad, cosecant x cotangent x dx. Again, we have the negative issue, so it's going to be the it's going to be the derivative of negative cosecant x plus a constant. Secant x plus c. So I actually have these 1, 2, 3, 4, 5, 6 new known forms, 4 of which are actually integrals not of trig functions, but of secant squared, of secant tangent, of cosecant squared x, of cosecant cotangent x. So of products of trig functions. So we need to then go and say, well, if I have all of these known forms, by the way, you should memorize them. Make sure you know them all. The more you practice, the easier it will be to memorize them. So to memorize. Now, though, the question becomes, how can I find the antiderivative of those other functions? We're going to start with tangent because it's the simplest. And here we will have what about the integral of tangent x dx. So in order to do this integral, we're actually going to have to use a substitution, the substitutions that we've been seeing, but we're going to also have to use a trig identity. So hopefully you guys remember that necessary identity that tangent x can actually be written as sine x over cosine x. And this is what makes trig functions so cool, is because they can actually all be written in terms of just sine and cosine. We can all kind of write them in terms of each other. So to do the integral of tangent x, I'm going to start off by rewriting tangent x as sine x over cosine x. And now I want you guys to take a second to think about it. What would be a good u for this problem? Hopefully, if you want to think about it for a second, pause the video. Hopefully you'll arrive at the idea that u equals cosine x is a good u because it's the denominator. And we've said sometimes u is the denominator is a good plan. But more than that, we just remembered up here the derivative of cosine is negative sine. Its derivative is in the numerator. So we also have the derivative right there. So this would be negative sine x dx. And then I just have to, multiply by a negative up here so that I have my du. So that right there is my du. And then I'm going to stick a negative out front here. And when I write this in terms of that u, I'll end up with negative the integral of 1 over u du. That's a known form. That gives us negative natural log of the absolute value of u plus a constant, negative natural log of cosine x plus c. So here we see that using substitution was incredibly useful for finding the integral of that trig function. That said, hopefully you can just memorize that. We're going to add it here to our list of known forms. Negative natural log of cosine x plus a constant. Now, I want you guys to take a minute to try to find the antiderivative of cotangent x. So now let's look at what about cotangent, the integral of cotangent x dx. So here, I'm just going to tell you that the necessary identity is that cotangent x is, I want to write that in red, actually, or pink. Cotangent x is actually equal to 1 over tangent x, or in other words, it is cosine x over sine x. So I'm going to get you started on this problem. I want you to do the integral of cosine x over sine x, of cotangent x dx, which is the same thing as the integral of cosine x over sine x dx. Now think about how we just did the integral of tangent, and I want you guys to pause the video and take a second and do this. And when I look at your notes, I want to see that it is in your notes. In the meantime, I am just going to write it down. So this actually is going to give me positive natural log of sine x plus a constant. So you should memorize that, but I also want to see you doing it. Okay, so we saw that for tangent and cotangent, we could actually easily just use our trig identities. So for secant, our trig identities and substitution. For secant, I wrote that in the wrong place. Lovely. Cotangent is natural log of sine of x. It's positive. Sorry about that. So for cosecant and secant, it's actually a little bit more challenging. It involves some multiplication by 1 in a kind of weird form. So instead of doing it, I'm actually just going to give you guys these. Ln of the absolute value of secant x plus tangent x for secant, and ln of the absolute value of cosecant x minus cotangent x plus c for cosecant. So these right here are kind of new ones that did not come from derivatives. So you should really get on to memorizing those and making sure that you know them. Okay, so these are all our trig integrals. We have 6, 7, 8, 9, 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. And you need to not only know them when you see them, but you need to know that you know them. So in other words, when secant squared shows up, you need to be like, oh, that's a known form. I've got that. Or inside of a substitution, you need to recognize that if you can get to a secant squared, that's something that you'll know. So recognizing these known forms, being super comfortable with them is going to really help you in terms of doing substitution with these things. So we're going to go now and try to do a few questions using substitution. See you in the next video.